Hello students, again your Lalitha ma'am is back with the second part of acids, bases and salts. In the first part of acids, bases and salts, we have learnt about chemical properties and physical properties of acids and bases. Okay, in the second part of this video, we are going to learn about the concept of pH, and we are going to learn about different types of salts that are obtained from common salt. Okay, so without any delay, let us move on to the video. Okay, acids, bases and salts part 2. Acids, bases and salts. Okay, part 2. Right, dear children? You just go through all the concepts, and these concepts elaborately we are going to discuss, so that it will be very much useful for you for your preparation of IIIT Basara entrance exams. Okay, right? So second part of acids, bases and salts, we are going to learn about the concept of pH. What is pH? Okay, concept of pH. So in order to find the relative strengths of acids, bases, we are going to use the concept of pH. The concept of pH was first introduced by the scientist named Sorensen. Okay, Sorensen is the name of the scientist who invented the concept of pH. And pH is a scale or a measurement which is used for us to identify the relative strengths of acids and bases. Okay, that means how strong the acid is or how weak the acid is, that you can decide based on the concept of pH. So it's a scale to measure the relative strengths of acids and bases. Okay, so pH is equal to what? Minus log of H plus is called as pH. It is defined as what? Negative logarithm of H plus ion concentration. Negative logarithm of H plus ion concentration is called as what? pH. Okay, so pH is defined like this. Here, what is H plus ion concentration? We all have learnt that acids are made of what? Yes, hydrogen ions, isn't it? All acids have hydrogen ions are there in common. So H plus ion concentration means the amount of H plus ions that can be released when 1 mole of an acid is made to dissolve in water. Okay, when 1 mole of acid is dissolved in water, the amount of or the number of H plus ions that can be released, okay, that you call it as what? It's concentration. So H plus ion concentration means what? It is the number of, this you are going to indicate like this with square brackets. Okay, that means what? Molar concentration of H plus ions. Okay, now what does this H plus in square bracket indicates? Molar concentration of H plus ions. You call it as hydrogen ion concentration. Okay, so all acids are having what? H plus ions. Okay, so in order to find the relative strengths of H plus ions, in order to find the relative strengths of acids, we should be very much well known about the amount of H plus ions that are going to be released when 1 mole of an acid is made to dissolve in water. Okay, so H plus ion concentration you have to check. Generally for acids, okay, pH is always less than 7. Okay, that means H plus ion concentration, okay, it should be greater than 10 power minus 7. Okay, H plus ion concentration, if it is more than 10 power minus 7, then the substance is considered to be acidic in nature. Okay, same like that, if you are going to take H plus ion concentration, if it is found to be less than 10 power minus 7, the substance is said to be basic, and for this pH value will be greater than 7. Okay, and for neutral substances, H plus ion concentration is equal to 10 power minus 7. Okay, then you call it as neutral, and for that pH value will be exactly equal to 7. So if pH is equal to 7, you call it as what? If pH is equal to 7, you call it as a neutral substance. pH is greater than 7, okay, it will be basic, and pH if it is less than 7, it will be acidic. Okay, so this is how you are going to identify the strength of relative strengths of acids and bases. The less the value of pH, the more acidic the substance will be. Okay, there are certain substances which we use in our daily life where pH is equals to sometimes 0, and sometimes pH is equals to 1 or 0 point something like that. That means the value of pH, if it is very less, the strength of acid is very high. Okay, the less the value of pH, the less the value of pH, okay, now the less the value of pH, the more will be the acidic strength. Okay, now the more will be the acidic strength. So you have to remember like this. Okay, so very less pH value means more acidic it will be. Like you can take the examples of batteries. Car batteries will be having certain electrolytic liquids. Okay, that electrolytic liquid is considered to be what? Acidic in nature, whose pH is almost equal to 0. Okay, so that is highly acidic. Okay, concentrated you call it as, means H plus ion concentration is very less. Okay, then you call it as what? Acidic substances. Okay, so you just forget about H plus ion concentrations and all. Okay, so you have to remember, if pH is greater than 7, okay, then the substance is basic. If pH is equal to 7, the substance is acidic, and if equal to 7, the substance is neutral, and if pH is less than 7, the substance is acidic. Okay, you have to remember like that, right? So this is regarding the concept of pH. Okay, so like that you have based on this concept of pH, you will be having small numericals will be there, which we will be doing in the objective part. Like in the third part of this video, we'll do small numericals based on the concept of pH. Okay, and then now we have to move on to pH of the substances in daily life. What is the use of this concept of pH in your daily life? Where you are going to use this concept of pH in your daily life? Okay, so you have to understand this. Yes, concept of pH can be used in our daily life in the process of digestion. Okay, now in the process of digestion, see, for the process of digestion to happen smoothly, okay, HCl has to be released into our stomach. Okay, gastric juices, and along with that HCl will also be released into our stomach. Okay, that means actually HCl is what? Hydrochloric acid. Hydrochloric acid is acidic in nature. Such a strong acid is being produced in our body, in our stomach, in order to make the digestion process very quickly. Okay, so please understand this point carefully. Okay, sometimes we feel burning sensation in our stomach. Why we will feel burning sensation in our stomach? Okay, why we feel burning sensation in our stomach? Okay, that is because of acidity which is there in our body. Okay, then what is meant by acidity? If more amount of if more amount of HCl is released in our stomach, okay, that causes burning sensation in our stomach. Okay, so we don't feel like eating anything. Or if we are going to have excess of food, okay, than the required quantity if we eat, then also what we call acidity will arise. Okay, so in order to reduce that acidity, we use certain antacid tablets. Okay, so pH related digestive system, in the process of digestion, okay, in the process of digestion, the concept of pH is used. Okay, so in order to reduce the acidity in our stomach, we use certain antacid tablets like Eno you all know, isn't it? Eno. Okay, to reduce the acidity in our stomach, we use antacids. Okay, we use what? Antacids. What are antacids? Anti-acids actually. Antacids are mild bases. Okay, in order to neutralize the acidic substance which is produced in our stomach, in order to neutralize that, we use sodium bicarbonate or milk of magnesia. We'll use mild bases which are acting as what? Antacids. That means that reduces the acidity which is caused in our stomach. That means what? pH of the substance, if it increases, acidic nature decreases. Okay, if you are adding base, means what? pH of the substance increases, or the acidity which is there in our stomach, it gets neutralized, so that we get relief from that burning sensation. So there we use the concept of pH. Okay, and next, see, water animals. Okay, water animals are getting damaged. Okay, there is a lot much damage to the sea animals. Why? Because we are throwing the industrial waste into the sea water. Okay, without neutralizing the industrial waste, or without treating that industrial waste with lime water. Okay, we are not supposed to mix that in the outskirts, like in small ponds and rivers. We are not supposed to mix the industrial waste in that ponds and rivers. Why? Because the aquatic life which is there inside that will get damaged. Okay, why? Because see, industrial waste consists of what? Industrial waste materials. Industrial waste consists of too much acidic substances. Okay, now too much acidic substances. To neutralize this acidic substances, we need to add lime water. Okay, now lime. What is lime? Slaked lime. Calcium hydroxide you have to add. So that what happens? The acidic nature of that industrial waste gets neutralized, and after getting neutralized, if we mix that in the pond water or river water, then it will not cause any damage to the aquatic life which is there in the small nearby ponds and rivers. Okay, so there also pH of the substance is going to get reduced. Sorry, pH of the substance gets neutralized, so that what happens? Okay, there will not be any damage to the wild animals. Okay, water animals. Okay, so like this you have second application is there, and third application is pH of soil. Okay, please remember that soil pH keeps changing with the type of crops which we have taken. Okay, suppose if the soil is too much acidic, okay, then some plants will not grow in that soil. Okay, then you have to neutralize the acidic nature of soil by mixing certain basic substances like urea. Okay, urea and lime, calcium phosphate or superphosphate of lime, like that. Even calcium hydroxide we use in order to neutralize the too much acidic nature of what? Soil. Okay, same like that, pH of soil, sometimes it is being basic also. In such cases, what you will do? Okay, if the soil is too much basic, then you have to add inorganic manure like organic manure like cow dung. Okay, cow dung or animal excretes. Okay, if you are going to add them, then the acidic nature retains back, so that actually soil gets neutralized and it will become suitable for the growth of next crops. Okay, so pH of soil, based on this what you have to learn? If soil is too much acidic, then what you have to add? In order to neutralize it, you have to add urea. Okay, urea and lime. Urea and lime you have to add. Suppose if the soil is too much basic, okay, now if the soil is too much basic, then what you have to add? Then add cow dung. Okay, now cow dung or animal excrete. Cow dung or animal excrete you have to add, so that in order to neutralize that soil acidic nature or basic nature of that soil, you have to add like this. Okay, so these points you will be getting in objectives, my dear children. Okay, where you are using the concept of pH or using the concept of neutralization in your daily life. Okay, so like this. And tooth decay, you all are aware of tooth decay. Why tooth decay occurs? Okay, why tooth decay occurs? Because if we are going to eat sweet tasting foods, okay, then pH of saliva decreases. Okay, the lactic acid which is present in our saliva decreases, so that it starts to act on the enamel of our teeth. Okay, now it starts to act on enamel of our teeth. Then teeth enamel gets damaged, which causes damage to our even teeth also, as well as we get stinking smell also. Okay, so tooth decay, concept of tooth decay. Why tooth decay occurs? When we eat sweet tasting foods. Okay, sweet tasting foods damage the teeth enamel. Okay, sweet tasting foods damage the teeth enamel. What does teeth enamel consist of? Teeth enamel, okay, now the coating, the white color coating which is there on our teeth. Okay, teeth enamel consists of what? Calcium phosphate will be there, Ca3PO4 taken twice. This calcium phosphate starts to decompose, okay, when we are eating sweet tasting foods. Why it happens like that? In saliva lactic acid will be there. Okay, pH of saliva decreases. Okay, pH of saliva decreases, lactic acid will be there. pH decreases if you are eating sweet tasting foods. Okay, pH becomes less than 5.5. Okay, pH becomes less than 5.5. Then what happens? It starts attacking your teeth enamel. Teeth enamel consists of what? Calcium phosphate. Now if it is attacking the teeth enamel, that causes tooth decay. Okay, and your teeth also gets damaged. So this is also the concept of pH, where we are using it in our daily life. Okay, and next you are going to have one more important point, that is what? Milkman adds baking soda to fresh milk. Why he adds? Milkman adds baking soda. What is baking soda? Did you remember? Baking soda is NaHCO3. Okay, sodium hydrogen carbonate is called as baking soda. Baking soda he adds to fresh milk. Why he adds that to fresh milk? In order to keep the milk fresh for long time. Okay, why it keeps the milk fresh for long time? As I already told you, like how you find lactic acid in your saliva, same like that milk also consists of what? Lactic acid. Okay, so that lactic acid gets neutralized with the addition of sodium bicarbonate. Okay, it gets neutralized. Once the lactic acid gets neutralized, the pH of saliva increases and acidic nature decreases. Okay, once if it gets neutralized, there is less chance for spoiling of milk. That's why milk remains fresh for long time if you add baking soda to fresh milk. That's why milkman adds baking soda to fresh milk. Okay, this is also one of the important applications of what? pH or neutralization reactions. Okay, and next you have certain plants like dog plant and nettle plant. Okay, dog plant, if you are going to touch that plant, we are going to get burning sensation or skin irritation we will get. That is because of what? Release of formic acid into our skin. Even red ants release formic acid into our skin. Look at this point, red ants. Okay, what they release? Formic acid into our skin. Formic acid. Okay, so because of this we get what? Our skin gets burning sensation, skin irritation you will get. Okay, so red ants, if they bite us, the bite of red ants is acidic in nature. Formic acid it will get induced into our body. In order to reduce this burning sensation, we have to rub the area where red ants bite is there. You have to rub that area with soap solution. Okay, so here what is happening? It is acidic in nature and soap solution is what? Basic in nature. So in order to neutralize the harmful acid which is released by red ants, we are using the remedy. Remedy is what? Soap solution. Okay, now remedy is, for that remedy is what? Soap solution. Okay, So this is also one thing. And sting of wasp is basic actually. For this you need to treat this with vinegar. Okay, sting of wasp is basic. Wasp, okay, in our daily life we see wasp, okay, a big kandiriga type. Okay, so sting of wasp is basic. In order to neutralize the basic nature of the sting, okay, we used to apply a little amount of vinegar in that area, so that what happens, that basic nature gets neutralized with vinegar. Vinegar is acidic in nature, it is acetic acid. Okay, so that pH decreases and it gets neutralized, so that we get relief from that pain. Okay, same like that you have lot many examples where the concept of pH is being used in our daily life. Okay, in order to make your skin tone more even tone, okay, we use a substance called what? Lactocalamine. Okay, lactocalamine is what? Zinc carbonate. Okay, it consists of zinc carbonate. Okay, so in order to make certain beauty products, we use the concept of pH because it should be suitable to all types of skins. Okay, same like that we have to prepare certain medicines as well as body lotions. All these are prepared based on the concept of pH only. Okay, or based on the concept of neutralization. Okay, for the ad which is there, like in Dove ad, if you see, it will be checked with the color change with the pH paper only. Okay, so if the soap is too harsh, which consists of two harsh chemicals, okay, then if it turns to dark blue color, more basic it will be. Okay, which is not suggested for our mild skin. So accordingly, based on the pH value which suits to our skin, we have to choose that particular cosmetic substance. Okay, so making of cosmetics, making of pharmaceuticals, making of medicines, all these are based on the concept of pH only. Okay, so that's why the concept of pH or the concept of neutralization is very much important to learn in our daily life. Okay, right. So next we'll move on to the salts, family of salts. What are the different types of salts that are obtained from common salt? Okay, salts are produced in what way? Salts are produced by neutralization reaction. Okay, now neutralization of acid and base to give salt and water. Okay, so acid plus base gives rise to what? Salt and water. This is called as neutralization reaction. Okay, here salt is formed. Okay, if the acid is strong and the base is weak, okay, then the so formed salt will be acidic in nature. Suppose if the acid is weak and the base is strong, okay, if the acid is weak and the base is strong, then the so formed salt is basic. Okay, and if both are weak, or both are strong, actually if both are weak, here no salt hydrolysis will take place. No salt hydrolysis means salt cannot be hydrolyzed. Salt hydrolysis cannot take place. Okay, if both are strong, like acid is also strong, base is also strong, then the so formed salt will be neutral salt. Okay, so in case of first case, if you go for an example, okay, if you go for an example where acid is strong, base is weak, okay, like you can take the example of HCl reacts with NaOH, base is weak, means NH4OH will take. NH4OH means ammonium hydroxide. Then you will be getting what? NH4Cl, okay, plus H2O. Okay, the so formed salt is what? Acidic salt. Acidic salt. Suppose if you take the example for the second case where acid is weak and base is strong. Acid is weak. For that we take the example of acetic acid, which is considered to be weak acid. Okay, and the strong base is NaOH. The so formed salt is what? CH3COO Na. sodium acetate plus water. This is basic salt. Okay, because base is strong, acid is weak. In order to make the salt with neutralization process, here base taken is strong, acid is weak. So the resultant salt is basic in nature. Okay, if you take for the both to be weak, means I take weak acid to be CH3COOH plus weak base is like NH4OH, then you will be getting CH3COONH4. Okay, CH3COONH4, ammonium acetate will be formed and cannot undergo hydrolysis. Okay, this salt cannot undergo hydrolysis. Hydrolysis means what? Actually, these salts splits into their ions, isn't it, when they are dissolved in water. But salts like ammonium acetate cannot split in water. That means both are weak. The salt is formed by weak acid, weak base. Okay, hydrolysis will not take place there. Okay, so you have to write like that, and along with that, of course, water is produced. Okay, case 4, if you take both strong, like first example, every time we take this only, HCl plus NaOH gives rise to what? NaCl plus H2O. Okay, here this is neutral salt. The salts which are formed by both strong acid and strong base will be neutral salt. Okay, so like this, salts are produced by what? Neutralization of acids and bases gives you salt and water. Okay, so NaCl, okay, is the common salt, you know. Okay, common salt. Now if you perform the process of electrolysis, okay, electrolysis of brine solution, this aqueous solution of NaCl, you call it as what? Brine solution. If you perform the process of electrolysis of brine solution, you will be getting at cathode, okay, you will be here brine solution means it is aqueous solution. At cathode you will be getting hydrogen gas will be liberated at cathode, and at anode you will be getting chlorine. Okay, now chlorine gas, and you will be getting a byproduct of NaOH. Okay, now byproduct, and this process you call it as what? Chlor-alkali process. This process is called as what? Chlor-alkali process. Chlor-alkali process. Okay, why it is called so? Because chlorine is released and one alkali substance, that is what? NaOH is also released during this process. Okay, so that's why it is called as what? Chlor-alkali process. So you will be getting questions like what is the byproduct which is formed by chlor-alkali process? Then immediately you will be answering, it is the byproduct is NaOH. What is NaOH? Sodium hydroxide. How does it appear? Yes, sodium hydroxide appear in the form of small pellets, okay, like tablets. Okay, and it is basic in nature, you all know that. Okay, and you are not supposed to touch anything with your bare hands, because that causes burning sensation. Okay, so like this, right? This process you call it as chlor-alkali process. Okay, salts obtained from common salts are what? Other salts if you take. Okay, other salts if you take, we come across Na2CO3, which is called as what? Sodium carbonate, which is called as washing soda, you will get. Okay, washing soda. Second type of salts you will be getting from sodium is baking soda. NaHCO3 is what? Baking soda. Okay, baking soda. And you will also be you will be getting even the other types of salts also. If you are going to add some chlorine gas to calcium hydroxide, you will be getting bleaching powder. Okay, bleaching powder. Okay, first let us have an idea about Na2CO3. It is called as what? Washing soda. What are the uses of washing soda? Generally any carbonate salts, okay, like Na2CO3, washing soda, in the name itself it is there, use it for washing of clothes. Okay, and the main usage of this is to remove permanent hardness of water. We use both the salts to remove permanent hardness of water. Permanent hardness. You know hard water? Hard water is the type of water which consists of chlorides and sulfates of calcium and magnesium in it. Okay, so by adding these carbonate salts, the hardness of the water can be reduced or it can be removed permanently also. Okay, so to remove permanent hardness of water, okay, hard water means the water which does not give foam or which does not give lather with the soap. Okay, so that is first usage of Na2CO3. Okay, it can be used in fire extinguisher. Okay, used in fire extinguishers. Okay, used in fire extinguishers because CO2 will be liberated. Okay, in order to extinguish fire, carbon dioxide has to be liberated. So this carbon dioxide acts as a fire extinguisher actually. Okay, right, and this sodium carbonate can be used as I told you. I didn't write about cleaning agent. Okay, now as a disinfectant or as a cleaning agent or a disinfectant, it can be used like that. Okay, whereas baking soda, in the name itself it is there. Actually speaking, this baking soda is a mixture of baking powder. Actually you will be getting questions on this. Baking powder is a mixture of what? Baking soda and tartaric acid. It's a mixture of baking soda plus tartaric acid. Okay, now tartaric acid. So what is this tartaric acid? Where do you find this? This tartaric acid is generally the one which is obtained from what we call tamarind pulp. Okay, now tamarind pulp of tamarind consists of this tartaric acid. Okay, so tartaric acid and baking soda together you call it as what? Baking powder. Okay, so baking powder is what? Sodium hydrogen carbonate, NaHCO3. So if you go for the uses are what? It is also used to remove permanent hardness of water. Okay, it is used as a fire extinguisher, as a mild antacid. Okay, mild antacid. Okay, used in fire extinguishers. Okay, it is also used in fire extinguisher in order to extinguish fire with the release of carbon dioxide gas. Okay, and this you will be using in eatables to make cakes soft and spongy. To make cakes soft and spongy, we use baking soda. Okay, so why cakes are made soft and spongy? When you are preparing the dough itself, if you are going to add this baking soda and even a little quantity of vinegar also being added to the dough, then by the mixing of these two substances, it results in the release of carbon dioxide gas. Okay, now carbon dioxide gas which is released gets trapped in the dough. Okay, now it gets trapped in the dough, and that's why the cake, while baking, the cake remains soft and spongy. Okay, so that's why it is used to make cake soft and spongy, and it is used in the process of fermentation. Okay, now in the process of fermentation process, we use baking soda to idli batter or dosa batter, so that for the next day it gets fermented, and then also idlis and dosas also will come crispy as well as soft. Okay, so those are the uses of what? NaHCO3, sodium hydrogen carbonate, sodium bicarbonate. Okay, now let us move on to the one more important salt that is being produced, that has to be learnt about. Okay, which is being given in your textbook, is about bleaching powder. Okay, bleaching powder is produced by what? What is the formula for bleaching powder? Calcium oxychloride is called as bleaching powder. Okay, now calcium oxychloride, CaOCl2, is called as bleaching powder. What are the uses of bleaching powder? Yes, it is used as a best bleaching agent. In the name itself it is there. It is used in leather industries or in textile industries, okay, in order to clean the leather or cloths. Okay, so bleaching powder. And even in swimming pools also, they add this bleaching powder so that algae should not form. Okay, and at the same time for water supply also, during the supply of water, in order to in order to kill the germs that are being produced during rainy seasons or whatever the water it may be there, before the supply of water to different houses, okay, from certain reservoirs and all, before the supply they add what? Bleaching powder. Okay, tap water, okay, municipality water will be there, no, that water, in that water we add what? Bleaching powder, so that it kills the germs that are there in the water. So that you call it as what? Chlorination of water. Okay, so this is about bleaching powder. And next you have another salt called as plaster of Paris. Okay, plaster of Paris, which is called as what? POP. For this, CaSO4 dot half H2O. Yes, this is what are the uses of this plaster of Paris? Okay, actually plaster of Paris is obtained from gypsum only. Calcium sulfate CaSO4 2H2O is called gypsum, whereas plaster of Paris is what? CaSO4 half H2O. Okay, what are the uses? You all are aware that these plaster of Paris is used for making Ganesh idols. Okay, now Ganesh idols, and for treating the fractured bones and all. Okay, if any fractures are happening, fractured bones and all are treated with plaster of Paris in order to take molds for your jaws. Okay, now for making artificial teeth, we use what? Molds of plaster of Paris. Dentists, they will use molds of plaster of Paris. Okay, and for making false ceiling. Okay, for making false ceiling, nowadays decorative interior decorations and all are happening, isn't it? So in order to have interior decorations, okay, we use plaster of Paris. Okay, so many settings you will be finding in Ramoji Film City. Okay, and in cinema sets, okay, they use lot many settings. Okay, that all are possible with what? Okay, plaster of Paris. Okay, so this is very important type of salt. Okay, please understand this point carefully. And plaster of Paris, of course, nowadays Ganesh idols are not we are not suggested to make or we are not suggested to use POP and Ganesh idols made with POP. Why? Because when they are throwing that in tank bund, okay, this POP is getting accumulated under the that tank bund area. Okay, and it is not getting dissolved. Okay, and it is remaining undissolved for lot many days, so that it is causing pollution, water pollution. Okay, that means what? Plaster of Paris is non-biodegradable. That's why we are asked to make Ganesh idols with clay only. Okay, not with plaster of Paris, even though it looks very good. Okay, but still this substance is considered to be non-biodegradable. That's why we are not suggested to use POP articles or Ganesh idols made with POP. Okay, so those are the different things you have to remember regarding plaster of Paris, right? And one more thing is, this plaster of Paris has to be always kept in airtight containers. Why it has to be kept in airtight containers? Because it sets itself into hard mass by absorbing water molecules. It is a salt of water of crystallization, absorbs water molecules. Okay, it absorbs water molecules from the atmosphere. It absorbs water molecules from the atmosphere and turns into gypsum. Gypsum is a hard mass, you know, and turns into gypsum. Gypsum is what? CaSO4 2H2O. You call it as gypsum. Okay, so that's why plaster of Paris always has to be kept in airtight containers. Okay, so this is also one important point you have to remember. And next, finally, we move on to water of crystallization salts. What are the different salts? Salts of water of crystallization. Okay, there are certain salts, okay, like which absorbs water molecules from the atmosphere but does not turn into liquid state. Okay, they remain to be like powdered state only. Water of crystallization. Okay, water of crystallization salts. Okay, salts of water of crystallization. So first example is what? CuSO4.5H2O, which is called as what? Blue vitriol. CuSO4 5H2O, blue vitriol. Okay, FeSO4 5H2O. FeSO4 5H2O, you call it as green vitriol. Okay, green vitriol. And then you have zinc sulfate, ZnSO4 7H2O, sorry 5H2O, you call it as white vitriol. Zinc sulfate is white vitriol. Okay, and you have Epsom salt is there. Epsom salt, MgSO4.7H2O, MgSO4.7H2O, you call it as what? Epsom salt. Okay, Epsom salt. This is also salt of water of crystallization. That means in these formulas you are finding .5H2O, .7H2O, something like that. Even CaSO4.2H2O is called as gypsum. Okay, gypsum. So these salts are water of crystallization salts. Means what? Salts which absorb water molecule from the atmosphere. Okay. Actually, if they are in sealed containers or sealed airtight containers, if they are there, they appear to be like colored like this. Or if you are taking them out and heating them, or if you are leaving them or leaving them to the atmosphere, then you will find different types of changes are observed in that salts. Okay, like if you take copper sulfate and heat it in a test tube, okay, then you will be finding the blue colored copper sulfate turns to white, and you will find water droplets are formed on the walls of the test tube, which indicates that what? That particular salt consists of water molecules, and that water molecules are coming out when you are heating that salt. That's why such kind of salts which are having water molecules hidden with them. Okay, now water molecules are hidden inside them. Okay, you will not find the salt to be in liquid state. You will find it to be in solid state only. Water molecules are hidden in them. They are being absorbed from the atmosphere and they are hidden. Okay, that's why such kind of salts are called as what? Water of crystallization salts. And if you are going to heat them, you will find the water droplets are formed on the walls of the test tube. Okay, and you will also observe a kind of crackling sound also. Okay, so this kind of observations you will make for salts of water of crystallization salts. Just remember what are the different salts which you have, which comes under water of crystallization. Okay, so this is all about different types of salts which is there in our class 10 textbook. Okay, so I request all the children to just go through the textbook. Happy learning. Okay, thanks for watching, and I always say your hard work is your superpower. Thanks for watching. Bye.